In this video, I'll show you how to make a wireless controller using a PIC18F252 microcontroller and nRF24l01 plus module with two 2-axis analog joysticks. Now let's jump right into the connections for the controller. Here you can see the connections between the microcontroller and the nRF24l01 plus module. For the detailed explanation of the transmitter configuration code, you can watch my previous video. Here on the diagram, we should also mention that the VCC of the nRF module should be connected to a reliable 3.3 volt power supply. In my configuration, I use the 3.3 volt output pin of the MSP430 launchpad, and the ground should be connected to common ground. The VSS pin of the microcontroller should be connected to common ground, and the VDD pin should be connected to either a 5 volt or a 3.3 volt power supply after you program it with the PIC3 module, since during programming the PIC3 provides the necessary power to the microcontroller. Here we can see our two 2-axis analog joysticks and their pins. Both of their grounds should be connected to common ground, and the VCC should be connected to the same power source you use for the VDD of the microcontroller, since this is going to be used as the reference voltage for the ADC module. And the 2-axis connections will be connected to the AN0, AN1, and AN2, AN3 pins of the microcontroller as seen in the diagram. Here in this diagram you can see the connections and components for the RC car. I won't be going into the details of this since I had already explained it in my DIY RC car video. Now let's see our setup and our C code in MPLAB X IDE. I will focus only on the ADC side of the code since it's the only difference from our previous transmitter project. Here you can see that in the infinite loop I'm going through the 4 analog channels by increasing an index named ADI, and by left shifting it by 3 bits I make an OR operation with the ADCON0 register. The reason for this is the channel selection bits are residing there. We can check it from the datasheet. And the ADCON1 register is set to hexadecimal 82. Because we will be setting the ADC to 5 analog channels and 0 reference channels, since we will be using VREF as VDD minus VSS. So we set the port configuration control bits accordingly, and we set the ADFM bit to 1, which is related with storing the 10 bits ADC result to two 8-bit registers as write justified. And ADCS2 bit is set to 0 for setting the clock conversion to FOSC over 2 in cooperation with the ADCS0 and ADC1 bits in the ADCON0 register. Then we enable the AD conversion with the AD is equal to 1 line and create a 10 millisecond delay to wait for the required acquisition time. Then we start the conversion by setting the go down bit, and with the following line we say that while the ADC module is busy, do nothing. Then we initiate the converted variable by resetting it to 0, and we do the operation of merging the two 8-bit result registers to a single value and assign it to the converted variable in the following 4 lines. And then we assign this value to the related element of our payload array. We form our 8-element payload integer array in which first 4 values are converted values. Then we send this payload from our transmitter to the receiver, which is an Arduino controlled RC car. Now we can use our joysticks and see the changes in the serial monitor of our receiver. As you can see, as I move the joystick on the right, in the x-axis you will see changes in the values of the third column. And for the y-axis, the changes will be seen on the fourth column. As I move to the joystick on the left, similarly I see changes in the first and second columns for the x and y-axis. And as I move both joysticks at the same time, I can observe the changes simultaneously. Now we will upload our RC car code to our Arduino via the Arduino IDE. This code gives us the control on two DC motors via the L298N motor driver. PWM is not enabled for the DC motor, so the car will go at full speed. And it can control two servo motors that can be used on the RC car. In this example, only one is active since I had broken one of the servo housing. So the first analog joystick will move the car, and only one axis of the second joystick will move the servo motor mounted on the car. For the connection and the details of this RC car, please watch my DIY RC car video. Now I will disconnect the USB cable since the car will be moving, so we will lose the serial monitor connection. And I will be mounting the lithium-ion batteries as the power supply. Now I can use the joysticks to control the DC motors and the servo on the car, as you can see in this section. I hope you enjoyed the video. If you enjoyed it, please click on the like button and consider subscribing to the channel for similar content about electronics, microcontrollers, and DIY projects. Thank you for watching.